simplify square roots. So remember, a square root is the opposite of a number squared, right? So they're going to give us some that are not perfect squares. So here, 80 is not a perfect square. They don't really want the decimal number of this, so they don't want you to go through and use your calculator to punch in the square root of 80. They're going to ask you to simplify down the squares. So it's going to end up looking like something that we worked with back a couple slides, where you have a number on the outside of the radical symbol and then a number underneath, okay? So we're going to have to use those steps that we just did, that prime factorization. So I'm teaching this slightly different than the book. If you get confused, you can go into the book and work that method. But the reason I didn't like the method that the book was using, it just left too much room for mistakes. The prime factorization method, unless you mess up between your prime numbers, there's very little mistakes that can be made. Okay, so here, if I do the prime factorization of 80, well, it ends in a 0, so I know 10 will go into that. And that would be 8 times 10. Okay, can I continue to break those down? Let's see, 10 would break down into 2 times 5. Okay, 2 is prime. It can't be broken down any further. 5 is prime. Okay, so for 8, so let's see, 8 breaks down to 2 times 4. Okay, 2 is prime. 4 will still break down to 2 times 2. Okay, so I'm done with my prime factorization. So I'm going to go ahead and I am going to write this out so that I can see all of the numbers in a row. So 2 times 2 times 2 times 2 times 5. Now, I know that I could write that out as 2 to the power of 4, which is how you would see it if they just asked us to do the prime factorization. The reason I'm not going to have you do that is now my next step is I'm going to go ahead and partner up common primes. So numbers that are the same, I'm going to put them into pairs. Okay, so let's see. Here's a pair of 2s. Here's a pair of 2s. And then I have a 5 left over. Okay, so my pairs, I'm going to put outside on the outside of the radical symbol. So here's my radical symbol. And I have a set of 2 and another set of 2. So I have a 2 times a 2. Yes, you're only going to write this 2 one time. Why? Because underneath of this square root, this is what it looks like right now. Okay, remember the square root is the opposite of something squared. Okay, so if I'm going to go through and do that, what I'm saying here is 2 squared is one of those is going to take care of one set underneath. So that's why I'm writing it out once. So the key thing here is I'm just going to go ahead and write out, if I have a pair, I just write that number once for each pair. Okay. Whatever's left over, I'm going to write underneath the radical symbol, so I've got a 5 underneath of here. Okay, so now I'm going to simplify where I can, and that would be, well, there's nothing left to simplify with the 5, but I could simplify out in the front, 2 times 2, which gives me 4, and then I'm going to write the square root of 5. Okay, the way that they taught out of the book was they asked you to list all of the factors of 80, and then find perfect squares. To me, it just left too much room for error if somebody didn't pick the perfect set. So that's why I went ahead and chose to just do the prime factorization. It's very visual where we can find those perfect squares by doing the partner concept. Okay, this is my final answer, 4 to the square root of 5, or with times the square root of 5. Okay, so let's go ahead and practice another one of these. Okay, so first step, we're going to do our prime factorization of those numbers underneath. Okay, so 300. Let's see, that would be 3 times 100. You could break it down into 60 times 5. I see 3 times 100. Okay, in the end, we should get the same thing. Okay, 3 is prime, can't be broken down. 100 could be broken down into 20 times 5, 10 times 10. I'm going to use 10 times 10. Okay, 10 can be broken down into 2 times 5. Okay, these are prime. They can't be broken down any further. So now I'm going to go ahead and write everything out. So really what I have is the square root, and then I've got 2 times 2. When you're writing it out, putting them next to each other so that it's very easy for you to see the pairs. And then I've got times 3 times 5 times 5. Notice, although I had my 3 clear over here, I still put them in order from smallest to largest. I put numbers that were the same next to each other. Okay, so now I'm going to look underneath there and I'm going to see if there's any partners. Okay, here's a set of 2s. and here's a set of 5s. So on the outside of my radical symbol, I get to write each one of those sets. I just get to write the number once for each set. So a 2 times a 5. And then whatever's left over that I didn't partner up, so those are gone and those are gone, I'm going to leave under that radical symbol, which is a 3. Okay, my next step is to now simplify each set. So there's nothing more to simplify with the square root of 3. There's not another number underneath of there. 2 times 5 would give me 10. My final answer is 10 to the square root of 3. Or times the square root of 3. I keep saying that incorrectly. Okay, 98. Once again, you can use your calculator to help you break down into your factors. I do not want that the square root of 98 is, let me see what it would be. I don't want the answer as 9.89. I want you to break it down so that you're left with that non-perfect square. Okay, so let's see, 98, if I break that down, it's an even number, so I'm just gonna divide by 2. So 98 divided by 2 is gonna give me 49. So 2 times 49. 2 is prime. 49 breaks down to 7 times 7. 7 is prime. It cannot be broken down any further. So what am I left with? 2 times 7 times 7. Okay, so I wrote out everything in order. I'm now going to see if I have any pairs. I see there's a pair of 7s here. So I get to write that once on the outside of the radical sign. So 7. Whatever's left over is going to go underneath or behind that radical sign, which was a 2. This is my final answer. This time I couldn't simplify in either set because there was no other numbers on the outside or underneath. So 7 times the square root of 2 is going to be my final answer. Okay, square root of 45. So the more you practice these, the more some of you are going to be able to kind of piece out and find those perfect squares within that. If I were to go through and just think, are there perfect squares that are within 45? I just think of, well, 9 times 5. I know that this is a perfect square. That's the way the book wanted me to do this with you, but I just felt that that was very confusing. So that's why I'm choosing to do the pair thing. Some of you are going to be able to do this concept. So if you'd like to try that, you can try it out. You could go back and look at the book and see how the book is doing it. Some of you are just going to be able to visually see, hey, I know 9's a perfect square and that's 3. And then what's left over is 5. A lot of you are going to need to see it this way. So if I break it down, 9 times 5, 5 is a prime number. 9 breaks down to 3 times 3. Those are prime. So I'm done. So I'm going to write it out. 3 times 3 times 5. Okay, do I have any pairs? Yep, there's a pair of 3s. So where do they go? They go on the outside of the radical symbol. And then I just have a 5 left underneath, so we're finished. So the square root of 45 is 3 times the square root of 5. And we're just going to leave it as that. We're not going to break it down into its decimal number. Okay, so I want you guys to break this one down. So go ahead and pause your video, work your way through prime factoring out, and then see, start your video back up to see what your final answer is. Final answer, you should have ended up with 2 times the square root of 6. So remembering that if you have numbers left underneath or behind that radical symbol, that like here I had 2 times 3, I have to go ahead and simplify those also. Okay, so that's working with simplifying square roots. Now what they're going to ask us to do is they're going to have us kind of combine some of those things. where they might have us simplify and then also have us work like we did on the first part of the slide where we were combining or simplifying.